Now let's show why we can do the convective adjustment the way we presented. Now to set it up, first let's have some notation here. So YF is the forward bond yield observed today for a forward contract with maturity T. Okay, so this is the forward bond yield. YT is the bond yield at time T, which is basically the realized bond yield at maturity. BT is the realized price of the bond at maturity. And sigma Y is the volatility of this forward bond yield. Okay, so this is a forward bond yield. This is the realized bond yield. Now, if we look at the price of a bond at maturity, it's basically a function of the realized yield at maturity. Now, suppose we expand this, so we expand the yield at maturity around the current forward yield, so which is a different number, but we expand it around here in the Taylor series expansion. We'll see that this thing is this one, which is we calculate based on using the forward, using the implied yield or from the forward price, or we just call this the forward bond yield. So the price as a function of the forward bond yield, then plus the first and the second derivative term here out of the Taylor series expansion. Okay, you're just expanding a function of this, so you will, straightly out of Taylor series expansion, you will have this. Now you observe, if we can take expectation, okay, takes expectation under some measure, basically. Then they say, okay, when we take expectation of this BT, the realized price, where the expectation is taken over a zero coupon bond from P0 to T, which means the zero coupon bond mature at T, and using that zero coupon bond as numerator. So you would take that expectation under that probability measure. We see that it's equal to this, because by definition, this is the forward price. The forward price is the expected value of the realized price. Okay, where the time of that realization or the payoff is at big T, so you take the expectation using zero coupon bond that matures at T as a numerator. So this is straightly out of the equivalent martingale measure theory. Okay, on that approach you can have this. So if you have this, that means this part has to be zero after you take in the expectation. So the expected value of this thing is going to be zero. So because they are linear, you can break them into two expectations, expectation of this part plus expectation of this part. Then what is the expectation of this thing here, the square? Well, the expectation of that square, yt minus yf square, is really sigma y square times the forward rate square times t. Okay, plus some higher order terms. Okay, so now you can just put in a substitution here, substituting this into here. And the expected value of this is equal to minus of that point, which is you substitute it here, is equal to minus 0.5 sigma square y 4 raised square times t from here, and times the second derivative here. Then rearrange, you'll find that your expected value yt is equal to this. Note here, when you have this expectation, you have expected yt. This yf is actually at the current point is actually a constant because this is a value derived out of the forward price. So the expectation of that is actually just itself. So and so you will get expected yt times g prime and minus yf times g prime. So you then move this yf times g prime to the right hand side. So and then divide by g prime. Then you will have this.